All right, making the video with the iPad today because yesterday's video didn't have audio, so it was like a silent movie, except not as exciting. So I'm going to record with the iPad today. So today we're talking about writing an exponential equation to model a given scenario and using properties of exponents to solve these equations using power functions. This is intense stuff. I've been trying to get you ready for this for a while. We'll see if it worked. All right. Do you remember where to put the starting amount? Here's one where you're growing by, let's say, 5%. Do you remember that the starting amount goes here? And that the ending amount goes here? And that the rate goes here? And that the time goes here? Does that ring a bell? Okay, so let's put in the stuff we know. She wants to put $500 in. What does that sound like? Starting, ending, rate, or time? Probably the start. Does it say how much there will be at the end? It doesn't specifically say it, but think about it. The doubling time will be 8 years. Didn't that tell us both a time and an amount? So the time will be 8 years. And the amount you'll have, if it doubles, is what? 1,000. And then it's 1 plus, what's the rate? What annual percentage rate? Well, it never told us a rate. It gave us a question word, so what do I put for that? R would be a logical choice. Do you get that you could solve that for R? All right. So let's solve that for R. What's my, let's just pause for a second and note, that was our time. That was our rate. That was our start. And that was our ending amount. That's what you're going to do every time. Okay. Unless we use a different formula, which they're going to introduce at the end of the lesson here. So who knows what I should, is it add, subtract, multiply, or divide at this point? What do you think? Divide. Divide both sides, because there's nothing to add or subtract. Divide both sides by what? 500. 500. Cancels. What's 1,000 divided by 500? 2 equals 1 plus r to the 8th. I can't add or multiply anything on both sides, so now I move up the food chain to exponents. What exponent could I put them to? To the what? 1/8. Why 1/8 power? Because 8 times the 1/8 will cancel each other out, and it'll be power of 1. And that means that you only have 1 plus r left. And 2 to the 1/8, I don't think anybody in here is going to know the 8th root of 2 off the top of your head. I totally get at that point you would need a calculator, and today's homework is definitely a with calculator experience. So everybody, grab your calculator if you need to borrow one from me. Come on up, give me some collateral, I'll trade you. Pausing. So when you take 2 to the 1/8, you got 1.09. And then, am I done? No. LV, what should I do next? And your final answer? And that's a what? Number of ricotta cheese slices? No, what's R? The rate. 9% rate. Do you get how I did that? That involved a lot of things. You had to know how to write the equation, and you had to know all these steps of solving the equation. All right. Let's do another one like that. One thing at a time. End is the start times 1 plus the rate to the time. That's the general format for these, right? Everybody stick in everything that you know. And solve for the thing that you don't know. I'm going to pause for a second while you give this one a try. Check with the kid next to you. What they want at the end is the rate. All right, I put in my starting and my ending price. Now I put 1 plus the rate. That's the thing I don't know. I'm going to call it R. The time, ooh, they made me figure it out. That's tough. 7 years. There. And you solve for R. I hope you divide it by 1.31 first. And then you put everything to the 1/7 power next, because that gets rid of the 7. And then you subtract 1. You could save the time and put it all in the calculator at once and say 3.15 divided by 1.31 to the 1/7 minus 1. And what would you have gotten? What rate was it? Like 13%, something like that? 133 if I remember right. 13.3%, I think. Could be off of my rounding, but okay. Cool. Let's try one more like that. This is an interesting one because elephants will grow more and more and more based on the amount of time that you give them. So, unlike a human, which does almost all of its growing in like the first 15 years, don't worry, some of you, you still have a chance. Michael Jordan grew 9 inches after high school. That's a lot. Okay, so anyway, an elephant, though, grows through its entire life. But do you get by using a cube root function? If you think about this, that means that they're growing less and less and less over time. Like a really old elephant might go an extra year older, but it only goes up like 1/4 of an inch in height. You know what I mean? But it grows a lot at the beginning. Okay, so this is just trying to train you about a different kind of problem where you take the number they give you and you just got to figure out where to put it. This 5-year-old would go into what? Height? No, time. So you just stick the number in the right place in the formula. So height, I don't know, is the cube root of 13 times 5 and then plus 3. These are so easy. There's problems like this on the ACT also. And it's also smart for you to know that all you got to do is look at the formula, stick the number in the right spot, and solve. And these problems often look really hard because it's like, it's a word problem. Oh my gosh, it's going to be so hard. If they give you the formula, it's so easy. All right, so somebody must have by now the cube root of 13 times 5, and then you added 3. I'm going to call on random person. It's row 5, person 3, a 1, a 2, a 3. RS, do you have this one?
7.02.
I remember that from a different hour, so she's right. How many of you had the same thing? Okay, good. All right, and then when will the average elephant reach 10 feet tall? I'll just be quiet for a minute. You put it in there and you solve it. Use your calculator. How many of you are actually already done? Just curious. It's only 2 people. Okay. Pausing for a second. You find out when typically the elephants get to be 10 feet tall. That's pretty impressive. They'd be bumping their head on the ceiling in here. Like you couldn't even lead your elephant in here. Pausing. I got the cube root question a lot last hour, and there is a way to do it on the calculator. I can't show you on my iPad, but I can tell you this way. 13 times 5, and instead of writing it with a cube root, I just write it with a to the, do you know what I'm going to say? To the what power? 1/3 power. Everybody knows usually how to do powers, so just do a 1/3 power. But here's the problem. People do figure out that this is 65, but they put it to the 1/3 and they type this exactly. To the 1 divided by 3. And they end up with like 20. And they're like, what? My friend got something totally different. What did they miss? They should have put something in. What should they put in? Parentheses. Because otherwise, you're telling your calculator to first divide by 1, and then, first put to the power of 1, which really doesn't do anything, and then divide it by 3. So you don't want that. So you want parentheses like that. Now there is a button, if you really want to know. There's a button that will allow you to do different roots. It is, let's see if I can find it. %, sure it's under the math, but I'm not completely 100% sure. There it is, math number 5. Okay. All right. And I'm feeling like you're understanding this, so I think we should just get right to the homework. So I'm going to pause for a second. Will you pull up the homework that's been assigned for tonight? And don't puke, because it's really long and I'm not assigning all of that. Okay, and I just realized that you're not quite ready for that yet. Because there's a thing called E that I didn't mention yet and is really important. So would everybody go to this yellow page? You'll be glad you loaded that onto your notes in a minute, because we'll have to use that worksheet. But please go back to this yellow page. I need to show you how to do something with E. All right. You'll see E in a second. First, we're going to make sure you get how to just do a normal exponential. So if I was going to do the starting amount of 4,000 times 1 plus what rate? 3%. It would normally have gone like this, and this would be your end amount. Your end amount would be 4,000 times 1 plus 0.03. But wait, they said compounded quarterly. Do you remember from our project? That means I'm going to have to change this to what?
Divided by 4.
Divided by 4 is correct. Very good. That's what quarterly means. So you divide that by 4. Okay. Then, how much money will you have in 3 years? This is where the time goes. And so you change that to 3 if you want to answer that question. Okay, so first I wanted to mention that. Next, we're going to, this one's a little easy, so we're going to go on to this one. Now, we have compounded things monthly before. That's this one. You divide the rate by 12, right? This is weekly. We divide by 52. And the thing that starts to get interesting is what you actually get when you multiply all of this out and put it to the power of 2.6, 2.7, 2.71, 2.718, 2.718, 2.718. Oh my gosh, it seems to, the bigger the amount of time we use, the more compoundings we do, hourly, every minute of every day through the whole year, or every second, it gets closer and closer to this number. You know what that number is? E. It's about 2.718. Yes?
On the yellow slide thingy.
Yep.
Why did we put X as like 3 times like 4? Because if we're doing year.
I get you. Well, I agree with you. When we get to more of those problems, I'll talk through more about making sure your units are right. You've got a good point about the units back on the yellow page, but we'll talk more about that in just a minute. All right, so back to this E thing. This E number is really important. It's like pi. Would you agree that somebody a long time ago told you what pi was? That it was about circles and it was 3.14 and it went on forever and never repeated. And then yet you've seen pi come up between then and now, right? It like pops up every now and then. This is your first moment on hearing about E. And he's going to keep popping up. All of next year, in calculus, it pops up again. E ends up being a really big deal. It's kind of like pi. It's one of those numbers that goes on forever and never repeats. Can anybody give me the name of a kind of thing like this that goes on forever and never repeats? Yes?
Is that irrational?
You are correct. That's an irrational number. Okay? So irrational numbers are like the square root of 2. It goes on forever. It never repeats. Or pi. It goes on forever. It never repeats. Or a third example you will now understand, e. E is this special number that can be used in compounding, and it's also got all these weird properties that are really cool in math. It ends up being the inverse of logs. Have you ever heard of logs before? Did you at least know that there's a button called log on your calculator? Okay, so it's an inverse of logs, and it also ends up being a really big deal in calculus. But this can be that first moment you saw E. And it came about because instead of compounding based on months or weeks or years or seconds, etc., like all the way down to the millisecond, you get closer and closer to E. Okay, so who cares? Well, this formula has E in it. It's called the PERT formula. P times e to the RT. And what this does is if something's changing constantly, it's not changing like 6% per year or per minute or per second. It's constantly changing. Have you ever heard of like carbon dating? So they get this old jawbone that they found in the ground, and then they like do carbon dating on it, because do you get that the carbon has been decaying like all the time? It doesn't like wait a month and then decay a little more and wait a month and decay a little more. You know what I mean? It's decaying constantly. Anytime something's constant like that, it uses E. Okay, so yay, you got a new formula. P is principal, or your starting amount. Remember how we always have a starting amount right there? It's just called principal now. P. E is this new number, 2.718, to the R times T. R is your rate, and T is your time. By the way, what if it's decaying? Then your rate's just negative. Very good. Okay. So let's actually do one that has E in it, because I thought we were done, but I forgot. This is the last thing. It's about E. And if you're feeling like, my gosh, there's been so many things, and I looked ahead at the worksheet, and it's massive, we're taking 2 days on it. Okay, so we're going to do the first day of that worksheet today. In theory, we could have just reviewed tomorrow and took a test the next day, but then I would feel like it's got really rushed at the end, and I don't want to do that to you because we are ahead of some other classes. So this is one of those moments we can slow down, make sure you totally got it, and we'll just test on Friday. That's my current plan. Friday tests are nice too because you don't have any homework on the weekend. So, all right. So let's do this last one. And remember, we're not doing the whole worksheet. We're just doing part of the worksheet tonight. Hint, PERT. Let's figure out where to stick the numbers in. P is principal. It's also the starting amount. And what was our starting amount? 250. Now, I usually don't use names in the video, but this young lady just said, on that other problem, Mr. Server, I think you messed up on the days versus the minutes versus the hours, and that's a really good point. This is one where they talk about per day, and then they throw in 36 hours. Do you get if I just use the number 36, my formula is going to think I'm doing it in days? And so I should not use 36 hours. I should do it in days. Does anybody have memorized what 36 hours is? A day and a half, so 1.5 days. So everybody cross off 36 hours and put 1.5 days. With that hint, see if you can finish this question. Your amount equals PERT. You can use a calculator. I'm going to pause while you give that a shot. Okay, student asked me if they should leave E in the answer or if they should just like get a decimal for E. And you should not leave E in your answer. You should use the decimal that comes up on your calculator for E. And by the way, where is it? Above the divide key. Everybody look above the divide key. Do you see the little E there? That's what you use. Now, is that actually perfectly E? No. But you got a pi key. What does the pi key do? It doesn't tell you perfectly what pi is. It just has a lot of decimal places memorized. Same thing with this. It doesn't really know what E is. Your calculator's not that smart. But it's got a lot of digits memorized, so it's better than you. 2.1 or 2.718's pretty good start, bud. All right, I'm gonna pause for a second while you get this answer. All right, we got 267.86. All right. Why hasn't it grown that much? I thought bacteria is supposed to like go crazy. We've only had a day and a half. I mean, it has gone up. It does go up 4.6% per day, but that's just a little more than one day, so it's not that much. One day would only been 4% growth, so it's gone up. All right. Now, do you get, since this is exponential, that if we did it for like a whole year, it would go up a huge amount? Okay. All right. So this one's only important. I'm going to save us the time of doing it. It says it has a decay rate of 11.55. What do you think we put in for our PERT, PE to the RT? What's special about this one? The rate would be what? Negative. Under the rate, you'd put in negative 0.01155. Thank you. And then the time, I don't think they tell us the time. Oh, no, wait. 24 hours. And is it in hours or is it in days? Okay, so since this is in hours, it's pretty easy to change 24 hours to days. But this says per hour, and this says for hours. If I keep it in hours, which is, just keep it 24. Okay, so the final answer would be 0.5 for P times E to the R negative 0.01155, 24, and that's just grunt work on the calculator. Super easy. Yes?
Wouldn't it be
Uh-oh.
0.1155?
You are correct. There's decimal is supposed to be there and there. You're right. Good catch. Okay. If I could, here, I'll zoom in on it. Put the decimal in black. Decimal's right there. Okay, so you're supposed to know PERT from now on. When do you use it? When things are happening continuously, not just by the day or by the quarter or by the month. When changes are happening all the time. Continuously. Then you use the PERT formula. Okay, so now let's take a look at that homework. Unfortunately, I'm not able to pull it up on my iPad for those at home, but I can tell you this. I'm just assigning the odds, and even that would be too much for today because we had a long session of learning. So all I'm going to ask you to do is the first, for tonight, the first 5 odd problems. We are going to have a lot of time to work more on this tomorrow. And then the next day will be review, and then Friday will be the test. Okay? First 5 odd problems. All right, that's all I have for you for today.